Alright, hey guys, this is 5.9, and in 5.9 our goal is to be able to build polynomials. We spent all this time working with them, learning how to find where they cross the x-axis, learning how to tell their graph behavior, when are they up, when are they down. There's a lot of things that we were able to discover about them, but one thing we still haven't been able to do quite is build them. Now, when we gather data, okay, so this is a sequential set of data. You can see the x's are going up by a constant amount. I'm going up by 1 each time. We look at this data, we can see that the data is trending downward to 1, but then it comes back up, then it goes back down to 1 and -5, then up and up. So it looks like there's sort of like a wiggle in it, okay, but how many wiggles and what's going to happen as I go further out? It's difficult to always know, is this an x to the third, or is this an x to the fourth, or x to the fifth? Like, how would I know? And how would I build a regression? We've done quadratic regressions, but you have to pick which type of regression to use. So there's a way that we can trick, or we can dig a little information out by using what's called the Nth Difference Test. Okay, and the way we do that is by taking a sequential set of data like this. Now, if it's real-world random data, there's a really good chance that this isn't going to work perfectly. But given that we've got a pretty nice set of data, it should work out really nicely. So it's kind of one of those things where we could figure out if there's a relationship that is quadratic or cubic if we ran this on real-life data. But if it's not, then we would know, okay, we're going to have an approximation for the model. So let's take a quick second and let's take how we're going to do this. The way it works is we take the number on the right minus the number on the left. It's really important that we're going 121 minus 17. So I'm going to use my calculator and do 121 minus 17. Some of you are going to say, oh, Mr. Welch, it's so easy. Why would I use my calculator? There's a lot of mistakes made here, okay? And then I'm going to do 17 minus a -5, and keep track of that negative, okay? That double negative is going to make it into an addition to give me 22. -5 minus 1 should come out as -6. And if I make a mistake, you guys can yell at me on the computer. 1 minus 5 would be -4. 5 minus 1 would be +4. 1 minus 7 would be -6. And 7 minus 65. 7 minus 65, calculator says, is -58. Now, if these numbers matched, this is what's called the first difference. If these numbers matched all the way across, that would mean that this is a straight line. And we could run a linear regression. But because they don't match, we have to go further. It's possible that they come out squared or so on. So I take 104 minus 22. 104 minus 22. And I get 82. And now I take 22 minus a -6 to get 28. So right now, I know that these numbers aren't going to match. So this is not a second degree polynomial. It's not a quadratic. But I can't tell what it is until I've gotten through enough numbers to have the pattern show up. So -6 minus a -4, it's like plus a 4, that's -2. -4 minus 4 would be -8. Lots of 8s and 2s in this line, that's kind of cool. 4 minus a -6, it's like addition, that becomes 10. Ruined my pattern, although 2 plus 8 is 10. And then -6 minus a -58, so -6 minus a -58, just wanting to make sure I get everything right, is 52. So it did not match, but let's keep going. 82 minus 28 comes out to 54. 28 minus a -2 is 30. So I know it's not a third degree. It's not cubic. Okay? If it was, these numbers would be matching. But we're going to keep rolling. -2 minus a -8 is like addition. That should become a 6. And -8 minus 10 is -18. And then 10 minus 52 would be -42. Not matching numbers. Now, we go one more. Let's see what happens. 54 minus 30 is 24. 30 minus 6 is 24. Don't get too excited. It has to work all the way across. 6 minus negative 18 is 24, and negative 18 minus negative 42 is 24. These matching numbers tell me that there is an equation that will perfectly model this set of data, and that it is a fourth degree polynomial. Now, on a graphing calculator, if you're using a graphing calculator, we're going to turn it on, and we're going to go right here to Stat. Then we're going to edit our data. In L1, we want to put our x's, which are negative 4, negative 3, negative 2, negative 1, 0, 1, 2, and 3. And then we come over to L2 and we give our y values, which are 65, 7, 1, 5, 1, negative 5, 17, and 121. Okay, so now I'm going to go back into Stat. I'm going to slide over to Calc. We did this on the last test, but we always ran a quad reg because we knew it was quadratic. That was the chapter we were in. This chapter has a lot of options. And the good news is they're in order. Linear regression, number 4, would be a first degree polynomial. Quad would be second degree polynomial. So 5 would be our second degree. Cubic would be our third degree. And the only other one that we're going to do in this chapter would be quartic, which is our fourth degree. So because we have fourth degree, we are choosing quartic. If it was a different level, we'd choose a different regression. We're going to enter down. It gives us an A, B, C, D, and E, because A is x to the fourth, and we work our way down. So 1, 3, negative 2, negative 8, 1. I'm going to write that down real quick. 1, 3, negative 2, negative 8. Let's get that back up. And 1. And 1. That means I have x to the fourth plus 3x cubed minus 2x squared minus 8x plus 1. That y equals that is the perfect equation for fitting this data, or at least the best case scenario. Let's take a look at what would happen if I don't have a graphing calculator with me. We would be using, we'd have to be using an Excel spreadsheet. Well, the good news is it's pretty easy to use the spreadsheet here. So let's go ahead and we're going to just put in our x's here. I think we started with negative, what was it, negative 3, negative 4, negative 4, negative 3, negative 2, negative 1, 0, 1, and 2, I think. I think we went to 3. It started at 65. Let me look at my list here. 65, 7, 1, 5, 1, negative 5, 17, and 121, I think. 121. Okay. So I've got all this data. I'm going to select it, and I'm going to choose to insert, and I want to insert a scatter plot. Okay? And we'll just do a random scatter plot like that. So you can kind of see the curve of a W almost. Okay, you can kind of see it in there. That tells me fourth degree is a pretty good fit. So just graphing this might be enough to know which kind of polynomial to run. Now, if you're having issues with running these equations on here, you know, come and see me. Use a calculator when you're here. You know, write down the steps. Imagine you're going through it, but at least figure out what degree polynomial it is, so it'd be easy to run the calculation. I'm going to select this data and right-click. I want to add a trend line. Now, if I run a linear trend line, it's a terrible fit. But if I go to a polynomial, there's my second degree. That'd be a quadratic. I want to move the order. It's called the degree in our class, but we're going to talk about it as the order here. If I moved it up to third, still not a great fit. But when I move it to fourth degree, see how well that fits? And then I want to display the equation on the chart. If we look at that equation, I'm going to pull it up here. If we look at that equation, that's 1x to the fourth, 3x cubed, minus 2x squared, minus 8x plus 1. Same equation we had on the graphing calculator. So whether you have to use Excel or use the graphing calculator, if I have to help you during the test with the graphing calculator, that's fine. But what I won't help you with is this process here, where you figure out which degree it is. If you need help with the technology in terms of figuring out how to run the regression, that's not a big deal. But you better know which regression you're running. All right, hopefully that's enough to get you through what you need. I'll see you in class, and good luck.